SWMM is a dynamic rainfall runoff simulation model used for single event or long-term simulation runoff quantity and quality from primarily urban areas. The runoff component of SWMM operates on a collection of subcatchment areas that receive precipitation and generate runoff and pollutant loads. The routing portion of SWMM transports this runoff through a system of pipes, channels, storage devices, pumps, and regulators. SWMM tracks the quantity and quality of runoff generated within each subcatchment and the flow rate, flow depth, and quality of water in each pipe and channel during a simulation period comprised of multiple time steps. Let us begin with the SWMM application. So this is the study area map of the SWMM application. To begin, let us first start with some general settings. Let us change the flow units to metric system, that is CMS. Let's go to option, general. Here the infiltration model or the routing model can be selected. Also the dates, that is where we start our analysis on and where we start our reporting on, can be selected here. And the time steps can be selected. We can also add an image to our study area map on which we can draw our subcatchment and channels. For simplicity, let us draw over a blank background. We go to add subcatchment tool and draw over the study area map by right clicking the mouse button, and to finish we click the left mouse button and create the subcatchment. The subcatchments need not to be of the specific shape, as the flow and routing depends upon the properties we enter for the subcatchment later. Next we add a junction node where the surface runoff would be entering, and we add an outflow node node. Next, we need to add the precipitation to our model. To do this, we add a time series of runoff of precipitation. We go to time series and add button, where we enter the name and we enter the time and value for our precipitation. Let us take for example 0 to 6 hours with the random values. The unit of these values will be selected later in the rain gauge. Let us add the rain gauge. We can edit the properties of the rain gauge by going into hydrology in the project tab and in the rain gauges selecting the name of the rain gauge, or by right clicking the rain gauge icon and selecting properties. Here we can change the rain format, that is intensity or cumulative or volume. Next we add the time series and we also select the rain units that we want, that is millimeter. Next we go to the subcatchment properties and assign our rain gauge to this subcatchment. We also assign the outlet that we want for this subcatchment. Next we enter the area in hectares and the width of overland flow path. This is not the physical width but the overland flow path of the subcatchment. We also enter the remaining properties, that is slope, the Manning's coefficient for impervious and pervious soils, etc. We can enter the infiltration data, that is for Horton's maximum infiltration, minimum infiltration, etc. and also for other such as green amped method. We enter this data for all the remaining subcatchments. I'm leaving one of the subcatchment to see if we get any errors. Next, I'll change the properties of the conduits. To add a conduit, select add a conduit from the toolbar and then draw from node to node. Once we have drawn the conduits, we can edit its properties by right clicking on the conduit or from the project tab. We select the shape, which can be rectangular, trapezoidal, etc. from the menu given above. For irregular shape, we can enter a transect. The transect is nothing but the profile of the cross section. We enter the transect name and the station and elevation values. Here I am taking a random width of 8 meter with maximum elevation of 5. I am assigning this transect to every conduit, which can be different. Next, let us now run a simulation. As you can see, I hadn't assigned outlet node for the subcatchment 3. I'll and you can see the error type shown, that is, we have the second and third as star marked. That means we have not entered the property. We go to the subcatchment properties and see that the second and the third ring gauge and outlet are not entered. We enter them and then run a simulation again. We go to report and summary to see the total runoff and peak runoff of subcatchments. Next, we can also have a time series plot of uh, various properties such as flow depth, volume, velocity, etc. of subcatchment and nodes. For that, we go to the create a time series plot. Here we add the object we need to show in the graph and the variable we want to show versus time. Select OK. This shows you the graph for depth versus time for link 1. Thirdly, we can also create a profile plot. To do so, select the profile plot and enter the start and the end node and select find path. This will show you all the links in the profile and then we select OK. This gives you the water elevation profile for the link and the nodes. The time here is 0 hours 15 minutes. We go to the map tab and start running our simulation for the profile plot. This gives you real-time simulation for the depth and in the nodes and the channel.